I'm a senior lecturer at the University of Manchester. I research skin ageing with a particular emphasis on looking at skin of colour and how people with the lightest skin types and the darkest skin types, how they age, how healthy their skin is and what kind of influences from the external environment they experience to their skin. At Manchester we have a very unique setup. So we have an academic unit where we have the laboratories, we can take skin samples and really dissect what's going on beneath the skin surface. What we also have with our unit here in Salford is the ability to take healthy volunteers, take their skin, investigate what makes their skin healthy, take those biopsies over to the labs and really investigate what is going on. We're one of the only units in the country that is able to take these healthy volunteers, take their skin and study it down in the laboratory. A lot of people will study cells, understanding in a 2D dish what's going on with cells. What we're looking at is the whole piece of tissue, which is far more informative. We know that the skin has lots of different layers, there's lots of different cell types in there. How they interact is really important to understand that from a tissue rather than from each individual cell in a dish. The Manchester Patch Test Assay is a short-term screening protocol to be able to look at real-life use of a product in people, but in a much shorter time frame. So what we're really trying to do is recapitulate what would happen if you used a product topically for, say, 6 months in use in your home. But by using the Manchester Patch Test, we can apply these products under laboratory conditions to an individual and see within 2 weeks whether that product is going to be efficacious at repairing the skin. So there's a great deal of effort that goes into designing these processes. We have to have ethical approval to allow these studies to take place. And that involves actually making sure that what we're doing is the right study on the right people at the right time. We also make sure that we understand the power of the study. How many people do we need to recruit to a study that is ethical, so not too many people, but is enough to show statistically that these products are going to have an effect on the skin.
So the patch test is a way for us to test products. It involves wearing a patch for 12 days with several different products in each patch. This is then covered over with a waterproof plaster so that the volunteer can continue their daily activities, including bathing. It usually involves different products, so one will have active ingredients in, one will be the product without any active ingredients in, another one may be a different concentration of active ingredients, and then we also always include a baseline control with no product on at all, and a positive control, which is usually retinoin. Each product is around 45 microlitres, so only a small amount. So this would then be applied onto the dorsal forearm. We chose this site because it's one that receives the most sun damage, so any effects of the cream will be greatly enhanced. This is then covered over with our waterproof plaster, and this allows our volunteer to carry on with their hobbies and showering whilst protecting the patches. It's changed every 4 days so that the cream is refreshed, so they can get the maximum dose, and then after 12 days they will come back to clinic and a small biopsy is taken from each site.
The power behind the Manchester Patch Test is each person is their own control. So we always make sure that we have a patch there that has no product applied, that just shows us what that person's underlying skin health is. We then apply different patches to the person and then we can compare the activity back to their baseline. So we can always tell each individual will have a different response to a product, but we can see, can you make improvement to that person's skin? And by having 10 people in the study, we can have the confidence that everybody has responded appropriately to that product. The tretinoin, or the all-trans retinoic acid, is seen as the gold standard for skin repair. So we know that there are many, many publications showing that if you apply tretinoin to the skin, you can repair collagen, you can repair the fibrillin. And so we have this as our gold standard that said, if that works on that person, then this is the benchmark at which we should measure these cosmetic actives.
Okay, so it's now day 12. After the volunteer has worn the patch for 12 days, they now come back, the patch is removed. Each one has been marked so we know which one is which. And just so we don't lose sight of where they are, we would then just put a little mark on each one. Lignocaine would be injected into each site so that the volunteer won't feel any pain during the process. A small 3mm biopsy, which is like a little tiny apple corer, would then be taken from each site in the centre where the cream was applied. This will leave a small wound, which is then closed with one stitch in order to provide a minimal scar as possible.
We chose the number of 10 volunteers simply because we know that that was enough power to show significant statistical differences in that study. It would also be unethical to use more people just because, we wanted to. We only choose the number of people that is necessary, and this just shows how effective, how those active ingredients really were efficacious in the skin. There's always a danger that your lovely product that people have enjoyed using actually doesn't have any effect deeper down in the skin. And so this is about taking that choice, asking an independent academic unit to go and test that product and say, did it work, did it not, in that patch test condition. So it's a leap of faith. There's a danger that your active might not work, but we can certainly tell you for our experimental design and our methods whether there was a efficacious result from your active ingredient. Historically, because we've always used it on white skin, we knew it worked in that skin type. We can now say, actually, it also works in darker skin types. We've published that research. So actually, there's validity for testing products across the world to make sure that the right people are receiving the right product and that they're not actually doing any harm to the skin. This is really important that, ethically, we need to make sure that people are using the right products, they're going to get a benefit from it, and that it's not going to overly irritate a certain skin type or someone with a certain skin colour. So we collect all our skin biopsy samples here at the clinic in Salford, and we take the skin biopsies and immediately put them into liquid nitrogen. We call this snap freezing, and this preserves the tissue there in the clinic, ready for further interrogation at our laboratories in the main university campus. At this point, the samples are blinded, so those scientists don't know which samples are which. They don't know which ones were the treated ones, which were the controls, which ones had the tretinoin added to them. So it's completely blinded at this point. The samples, when they reach the lab in the main university campus, they're put onto a machine called a cryostat. And this is a machine, a little bit like a bacon slicer, that's going to cut very thin sections of that tissue so we can then go and interrogate what proteins, what the structure is, what the skin looks like. So these sections are around about 7 to 10 microns in thickness, and we then use these, keeping them frozen, and start to add antibodies and look for what proteins are in the skin. These samples take about 24 hours to be processed. They're then transferred onto a microscope where we can actually photograph and image those sections and start to make these comparisons of what the skin looked like before and after treatment. But as I said, the samples are blinded, so the scientist really just looks at what there is in that particular section, and then at the very end of the study, we will unblind the code and interrogate then, well, okay, sample 1, that was maybe the treated one with the retinoid, or it was the treated one with the active, and we can make comparisons there and see what improvements have been made through the addition of those active ingredients. The original findings from something like tretinoin was that you could repair the fibrillin over the course of using it maybe for 12 months up to well into 4 years of use. And we can see that the same fibrillin that you could deposit using it on that real life daily use of the cream actually could be recapitulated in this 2-week long patch test. So you can put into the skin these fibrillin-rich microfibrils. The University of Manchester, as I said before, are completely unique in that we have this academic department teamed up with a clinical department able to do these real life, real people studies. But we also, because we are a university that is really focused on the academics, we are independent. We're not paid by these cosmetic companies to say that product works. The data, it doesn't matter to me whether it's positive or negative, the data. We're doing a study, it has the scientific rigour that shows that, we put this product on, what was the output? And we will do whatever we can. We're blinded to really what the product is, to what the ingredients are. We can merely say, did it improve fibrillin? Did it improve collagen? Did it have a benefit to skin health in those individuals using this patch test? This study is really unique because it is about taking actual skin biopsies. So everybody can do a study where you're looking at, does the skin look brighter, does it look healthier, does the consumer like it? That's not a problem. These are easy studies to run. They take a lot of volunteers to take part in them, but they're relatively easy to achieve. What we're really doing is taking the skin biopsy, we're cutting that into minute slices and looking down the microscope and saying, have we improved the skin before and after treatment? And this is a range of techniques that is unique. It can only be run in scientific departments. It needs a lot of technology and a lot of expertise and know-how. It's always difficult because we're working in the healthy volunteer sector. This is not something that you would have hundreds of people using, thousands of people using. This is asking people to give small amounts of biopsies to test a cosmetic product. What we do though with the studies is make sure that we write up a journal article that then goes to a prestigious journal who will peer review it. So people external from the study who have no idea what we have done will read and review and agree or not that we are drawing appropriate conclusions, that our results are scientifically robust. Using the patch test, it's really important that we understand the difference between applying the full formulation with everything there, the absolute formula that would go onto the market and be used by people. We need to understand the actives in that and what they're doing versus just the kind of the base, the moisturiser, the non-active element. Because actually it could be that the cream is lovely, but it's not the actives that are repairing the skin. It could just be the formulation itself. So in our patch test, we always make sure to include a baseline control, a vehicle control, so the base cream, and then the cream with the active. And then we can decide for the difference between having the active there and just the moisturiser and make sure it is the active that is doing the job, that is repairing the skin. There's lots of active ingredients out there that can have positive benefits on the skin. Retinoids, of course, we think of for the skin repair, the wrinkles, some of the dyspigmentation in the skin, but of course you can use niacinamide that has evidence that it will repair skin and will give it that luminosity. You've also got those peptides. Peptides are these things that will signal in the dermis to tell it to make more collagen or elastin. The difficulty is, of course, is that you can tell the skin to do lots of different things, but you need the proteins to be laid down in the right place, at the right time, in the correct manner. And that's one thing that we know with certainly the skin repair that we've shown in this patch test, that you actually can make the fibres come back in the right place, in the right orientation, and that's really important. It's exciting times ahead for us. So as somebody who works in these extremely small pieces of skin, we need to maximise what we can find our information from that. And now technologies have moved forward that we can start to look at the molecular level, the what we call the transcriptome, look at what genes are turned on as a result of applying actives and compounds. And so now we'll be able to start looking at in individuals what genes are working, where are they on, and why are they doing what they're doing. And this is really exciting technologies that are developing all the time.